Hello students, the next topic we are going to discuss is work kinetic energy theorem. It is very important topic of this unit. So here we are going to relate the work with the kinetic energy. This theorem is called as work kinetic energy theorem. Okay, so we know that work done is equal to force into displacement. So here displacement is represented by S, symbol S. Okay, so work done is equal to force into displacement. And you also know that according to Newton's law, force F is equal to m into A. Let this be equation number 1 and 2. Okay. So now what I am going to do is, and we also know some other kinetic equations because you are going to relate kinetic energy. So I am going for kinetic equations. V square equal to U square plus 2AS and A equal to, from this equation I am going to derive this. Okay. So you have V square equal to U square plus 2AS. So have this 2AS as it is. Then you will be having, bring this U square to the other side. You will be having V square minus U square equal to 2AS. You will be having it as V square. I will just write it as V and U. It is actually V square minus U square equal to 2AS. Okay. From this, I am going to take this 2 and S to the other side and have the A alone. So here it is in here in this part it is in multiplication. So you bring this 2 and S alone to the other side, it becomes V minus, that is V square minus U square. It is in the right hand side it is in multiplication, that is if you bring it to the other side it becomes division. So V square minus U square by 2S is equal to A. That is what is derived here in this part. So we have A equal to V square minus U square by 2S. Then now we have already found, we already gave the equation of force F is equal to m into A. So in this, to substitute A we have found. So substitute this A here in that equation. So we have F is equal to m into A. Instead of A, this part is substituted here. So F is equal to m into V square minus U square by 2S. Okay. So now I am going to multiply this m inside and write it as a separate part. So double F. Okay. F is equal to this would be, just multiply it inside. F is equal to m V square by 2S and then minus m U square by 2S. Okay. This would be the F value now. Then I have F, I found the F. What I did, I know F is equal to MA. In this I have found A value and then substituted the A value here and found the F value. Now substitute this F value in the first equation. Okay. So first equation, that is what we need. Actually kinetic energy should be related to work. So for getting kinetic energy, we have related the kinetic equation and then to F, then F into work done. So work done W equal to F into S. So this is my F term. Okay, and you have to go substitute this f here into s. So in this term you have to multiply the whole term with s. So add one s on each term. You have to multiply s on each term. Okay, then w equal to m into v square by 2s into s minus m into u square by 2s into s. Okay, in this case one s and s will get cancelled off. So when you cancel one s and s, you will simply have mv square by 2 minus mu square by 2. That is 1 by 2 mv square minus 1 by 2 mu square. Okay. So here you can see that this part, this is initial velocity, u is initial velocity and v is final velocity, and you can see that this 1 by 2 mv square is nothing but kinetic energy. So you have related work with kinetic energy. This is called work kinetic energy relationship. Okay, so the kinetic energy, v is nothing but final velocity, u is nothing but initial velocity. So you can write it as, this is difference between final value and initial value of kinetic energy. So just difference, isn't it? Difference can be written as del. So del k is nothing but difference in kinetic energy. This whole part is difference in kinetic energy. So this can be written as w equal to difference in kinetic energy. So this is the relationship between work and kinetic energy. I hope you have understood. Thank you.